Welcome to another episode of Physics Class Connect with Yusuf Arikewuyo. Today we shall be looking at the concept of motion. We'll be looking at what causes motion, of course some types of motion, and some practical application of motion. Motion can be defined as a change in the position of a body in an interval of time as a result of an applied force. When we talk about applied force, it can be internally generated or externally generated. For example, when a body is at rest and all of a sudden the body decides to change its position or start motion, we can say the body is being acted upon by an internal force. That can be likened to a situation whereby a child wakes from his or her sleep. And when we talk about an external generated force, imagine a ball at rest. Then a footballer comes and kicks the ball. The ball will change its position as a result of the kick from the footballer. In that case, we say the ball was under the influence of an external force. Different types of motion exist in nature. They are grouped generally into four, and they include linear motion, rotational motion, oscillatory motion, and random motion. We shall examine each type of motion individually and give relevant examples. The motion of a body is said to be linear if it moves on a straight path. In other words, the body moves without making a turn or a bend. For example, consider a car moving along a straight path. The car, as long as it doesn't make a turn or a bend, will be considered as moving in linear motion. Also consider the case of students or people running a 100-meter race. We all know that the motion takes place along a straight path. Such type of motion can be seen to be linear motion. Whenever a body moves in a straight path without making a curve, a bend, or a turn, we say the body exhibits linear motion. The next example we shall consider is the rotational motion. A body is said to move in rotational motion whenever it moves in a circular path. In other words, the body moves around a fixed point. Some bodies that exhibit rotational motion include the motion of the ceiling fan. That is, when a ceiling fan is on, the blades will be seen to move in a circular or a rotational path. Consider the second hand of an analog clock, a wall clock. We can see that the second hand moves in a circular path. Also consider the tires of a car, a bicycle. In motion, we can see clearly that the tires move in a circular path. These and other examples give examples of rotational motion or examples of bodies in rotational. Oscillatory motion occurs whenever a body moves in a regularly repeating manner, otherwise referred to as to and fro. These bodies make a to and also a fro motion. Examples of bodies exhibiting oscillatory motion include the motion of a loaded test tube in water, the motion of a pendulum bob, and of course, while pounding, we exhibit oscillatory motion. The last category of motion is what is referred to as random motion. A body exhibiting random motion moves in an irregular manner. Its motion or its movement is haphazard, it is disorganized. It can also be referred to as Brownian motion. Examples of bodies exhibiting random motion include the motion of dust particles in air, exhaust from a car, the motion of animals, and other motion that can't be placed to belong to linear, rotational, or oscillatory motion. As a quick recap, let's consider the diagram below. This shows a body moving in a straight path. We can't say the motion of this body is linear. For example, if the body decides to make a bend, we can no longer say this motion is linear because it has made a curve. Therefore, it doesn't suit the definition for linear motion. When a body moves in a circular path, as shown, then we can say the motion is rotational. Consider the blades of a moving fan. We have that the blades, this is actually a fan with three blades. When in motion, we can see that it makes a perfect circular rotation about its fixed center. When we say a body moves in oscillatory motion, it goes to and fro. In other words, it goes this way and returns back to where it started from. Did we get that? For random motion, consider the motion of gas particles in air. We can see that the gas molecules or particles scatter around to fill the entire place as shown. We can't really say where the gas molecules or particles will be at a particular instance. Thanks for watching, and don't forget to subscribe and click on the notification button to always remind you of our lectures. Thank you.